Good evening, all. How are you doing today?
Good afternoon, sir. I'm okay.
Yes,
Good afternoon, sir.
great. How are you doing?
Afternoon, sir. Doing good.
Nice.
Just cold.
Nice. You're cold.
Yes, sir.
Are you feeling sick?
No, sir.
Oh, well, kind of strange that you say that you're cold. Um, I was under the weather, and I'm using the operative was, and I mean Monday I was feeling out of it, really out of it, and I was here today working until home. Then went and bought food and came up and ate and everything. Sat down to prepare some notes for you on numbers, and then I just started feeling sick again. And trust me, what I want right about now is just to find my bed and just lay down and just sleep. It has been a rough period, but anyhow, we have work to do. I'm gonna give the others, what time is it now? It's now 5:39 at 9 minutes. Let me give the others another 6 minutes to come, and then we're gonna hit the ball running. All right?
Okay, sir.
Yes,
Yeah.
sir.
Cool. All right, let us go for this. So this is it. Officially the final teaching day. We have 1 week left for what is reserved as study week before your exam on Monday, the 23rd. So officially we have 10 days to the exam. Officially 10 days to the exam. For the most part, based on what I would have placed in the WhatsApp group, for the most part, I am about 95% done. I'm about 95% done. All right. There are 1 or 2 little mop-ups that I have to do that I'm going to be doing tonight. I'm going to be doing some tonight. Interspersed with some past paper questions. Next week, what I would love to do is maybe not for both days, Monday and Friday, or who to tell, but for sure, 1 or both days. I would just want us to come and just sit down and say, okay, work 20, 15, 16, 17, 18, 19, 20 past paper. I would just work the questions. I would just work until we're tired. I'm seeing in the group, people asking me to keep them up, when they start to work. And I think the reality now is sitting in, and people are beginning to be a little bit nervous, anxious, whatever attitude you want. But I'm just going to ask you to be relaxed. We would have covered, to be honest with you, if I don't teach you 1 more something, you should be able to go into the exam and do very well. That's the point I'm making. If I don't teach you 1 more something, based on the 16 topics that they've given you, I would have gone through 15 of those topics. And I'm going to do the 16th one tonight, and then 1 or 2 of the other little ones that I left out, 1 or 2 little stuff that I know that I'm aware of that I'm going to be doing. But nonetheless, even though fatigue has taken the best of us, this has been a rough week, guys. When I say rough week. Some days 2 meetings, some days 3 meetings. Yesterday I had a principal calling me when I'm talking to one of the vice principals. Then I'm talking to the other vice principal. Then I'm talking to this was a rough day. But anyhow, to whom much is given, much is expected. Let us just drop a 1 word of prayer now, as we invite the presence of the Holy Spirit to just reside among us. So we thank you, Lord, for what you've done and continue to do. You see the hearts, you see the fatigue, you see the desires to do very well. But Father, you know the limitations, the reservations. We commit them to you even now in the name of Jesus, and ask, Lord, that you will just take your individual concerns and struggles into your hands. I pray for clarity as I go through. I pray for receptive hearts and minds and thoughts. And I pray, Lord, that you just calm the nerves of these, my students who will be writing their exam on the 23rd and other exams to come on that day and or days to come. So, Lord, we thank you. We pray that you may bless the facilitators, that, Father, we can be able to provide that cushion on that tide, that encouraging word, touch, nudge, you name it, Lord, to encourage these our students. I pray for favor, that the questions will come in a manner that they can answer well. So we thank you. And I come against that spirit of sickness, Lord, the lethargic feeling that comes with it. makes you feel like you wanted nothing. So thank you for health and strength and daily food and the opportunity to learn. So continue and just come in this class. So now, let us go. So I didn't do numbers because numbers is pretty easy. Numbers is something we would do from little school. And as I was trying to find me a software to do it neatly, you know I have OCD. And oh Lord, you know I have OCD, and I'm trying to find it and can't find it, and then I just got frustrated. I just got frustrated. So let me share what I attempted to do. Maybe with our minds together we can figure it out. So don't ask me why I went to Smart Draw, but I went there to create something for you as it relates to the number system. So looking at the number system, let me talk about the real. And actually, the real number system, yes, just say that, let it stay. The real number system. I wonder if I can put in the symbols in this thing. Let me try, I don't know. I guess not. All right, so I'm looking at the real number system. Now, it has only 4 units. I had done, no, it had, the unit has 4 areas. I had done, call it 2 of the 4. But I didn't draw this thing here. So the real number system is broken up into real numbers and imaginary numbers. Real numbers and those that are imaginary. So real numbers and imaginary. So the real number system, yeah, it's 2 things. It's either it's real or imaginary. Now, for the real number system, we have things like even numbers, odd numbers, whole numbers, prime numbers, composite numbers, factors, multiples. Which other one have you wrote? What's your?
Integers.
Yeah. So why is the leaving so strong?
No, sir. My phone is working properly.
No, but I mean, me typing me saying it just behaving very strong. Okay. No, don't do this. I will. Come on, you don't. What's your? No, it'll be very strong. Actually, I don't feel I'm something else. I'm gonna try first. All right. No man, this thing. I don't know what that be. And then a line left. Yeah, probably like in one move. You know what we be. All right. And then now I need to join so that I can I can put my integers exterior code. Be careful here. It's math to teach. All right. So so the real number system speaks of, you know, all right, let me change something here. I'm going to change something else. Rational and irrational. So the real number system, I'm breaking it up into rational and irrational numbers. Rational and irrational numbers. So once you're talking about the real number system, you speak of either the number is rational or irrational. So any number at all can be grouped as rational or irrational. So let us look at some of the rational numbers. Some of the rational numbers talks about even number. Anybody can tell what an even number is? What is an even number? Hello, let me just tell you something. One of the calculus and multivariate functions and then big school something there. This is little school something. So just make it
What was
real.
the question?
Even numbers. What are even numbers?
So even numbers are numbers that can be divided evenly, like without leaving a remainder. Yeah.
Completely divisible by 2.
Thank you very much. All right, hold on.
Or they are divisible by 2.
Or multiples because it don't have to be 2.
So that means that nine is an even number then because it's evenly divided.
No.
Okay. So define for me an even number. And let me just warn you on something here, please. Let me warn you on something here. It is very common for us to talk about and don't leave a remainder. And we have studied the factor and remainder theorem where it was explicitly stated, no say, it does not leave a remainder.
True, sir.
Okay, thank you, please. Thank you, please. Remember now, when the remainder equals 0, it tells us that it is a
Factor.
Thank you, please. So let us speak the jargon because you see, it's part of the thing where I don't think speaking a jargon clear enough in class, so that's why I think the understanding isn't there. So let me hear somebody again with the definition of an even number. An even number is?
So you're saying that we must put 0 in the definition?
No, I didn't say you have to put 0 in the definition. No, I'm just saying when you say that you don't leave a remainder, I know that you're talking about 0. So when you say don't, right, but I mean, don't say don't leave a remainder because 0 is a remainder and 0 is indicative of something, right? So let me hear somebody define an even number for me now again.
As an even number is any number that when divided by 2 leaves no remainder or is 0.
Don't say don't leave no remainder, Nikki. When divided by 2,
And leaves a remainder of 0.
Leaves a remainder of 0. You see me use the 0 in other something, Nikki?
Yes, sir.
Right, it leaves a remainder of 0, right? So you can say a number when divided by, an even number is a number when divided by 2, it does so exactly. Does that make sense?
Yes, sir.
Yes, sir.
Good. Or when divided by 2, the remainder is 0. Does that make sense?
Yes, sir.
Yeah, man.
Yes,
So
sir.
we have to speak about numero dos, the number 2. We also have to speak about zero. If it is a doing the definition with zero, we can't say without leaving a remainder. And I'm going to tell you straight up, I was victim of that when my primary school teacher, who I to this very day I idolize, told me some foo-foo something in mathematics. So you carry it over the equal sign. Boy, I said, carry it over the equal sign. And when you carry it over the equal sign, the sign changed. Not a thing no go so. Not a thing no go so. I mean, I was abused mathematically, but fortunately, me kind of like the subject still, so that's why I kind of catch it, and then now as I study more and more of it, the truth just starts to unravel itself. But sometimes we don't even know ourselves because we often teach the way we were taught, right? So we have to get it. And even number is a number when divided by 2, it does so exactly, or when divided by 2, it leaves a remainder 0. All right? What is an odd number? What is an odd number? Hello, let me talk to the teacher.
Number that is divisible by 2 and leaves a remainder of 1.
Very good. So an odd number is a number when divided by 2, it leaves a remainder of 1. So if you can say that, why when you're talking about an even number, you will say it only in a remainder? But you're correct, Vashante, very good. So an odd number is a number when divided by 2, it leaves a remainder 1. Well, I tell them how the numbers are having now. As I'm speaking, more and more coming to me. All right. So what are whole numbers now?
Number without fraction, so like
It's like an integer.
Hold on. We're getting closer now. So a whole number is a number without fraction. It's like an integer, but we don't define integer yet, so you can't use integer. So tell me how would you define an integer then? What is an integer? Somebody talk to me now. What is an integer?
So a number which is not a fraction.
Oh, really? What is an integer, class?
Sir, a whole number.
Oh, really?
Sarah, integer is a whole number and a whole number is an integer.
Integer have a negative?
Negative or positive numbers.
Okay. You see what life funny though? We can integrate and differentiate and we don't even know what an integer is. Life is funny. Life is funny. What is an integer? I love it. What is an integer, class?
Sir, negative or positive number?
Okay, negative or positive number.
So it can be either a negative or positive fraction or whole number.
Okay. Interesting. All right, I'm coming back to that one. Because I'm not telling you, I'm coming back to that one. What is a prime number?
A prime number is a number which only has 2 factors, 1 and itself.
Excellent. Beautiful definition. A prime number is a number that has exactly 2 factors, itself and 1. Beautiful. Lovely. What is therefore the first prime number?
2.
Bueno. So 1 is not prime because a prime number is a number that has exactly 2 factors, itself and 1. So therefore the first prime number is numero dos. Very good. Bueno. All right. What is a composite number? What is a composite number?
More than 2 factors.
Okay. A composite number is a number that has more than 2 factors. All right. Okay. All right. I can take that. I can take that. I can take that. Give me an example of a composite number.
4.
How you know?
Because it has more than 2 factors.
Name them.
1, 2, and 4.
Excellent. All right. So I asked the question because what I want you to remember all the time is that 1 is a factor of all the numbers. 1 is a factor of all the numbers. Every single one of them.
So when you say it's a composite number, sir?
A composite number is a number that has more than 2 factors. So if the number is not prime, it is therefore
Composite.
very good. And if the number is not composite, it is therefore
Prime.
very good. So the opposite of composite is
Prime.
and the opposite of prime is, of odd is
Even.
even. Very good. All right. Very good. All right. All right. Whenever I teach this, I normally do an exercise. So we're looking at factors and multiples. We're looking at factors. Sorry, as I am talking, it's long time I don't teach this topic. So as I'm talking, all of them coming to me, natural and counting, and this is one of the things, you really can't unlearn something, you may forget it for a while, but as you get into it, it just keeps coming back to you. So as I'm speaking, a lot of these things are just coming back to me. And yes, sorry, I don't have the definitions written out. We're just talking it over. And as a matter of fact, I won't even write the definition because these are things that you should know. Factors. What is a factor? When I say a factor of a number is what? Describe for me a factor of a number. A factor of a number is
So is it one that can divide through another number without? Yeah, I don't know the next part. I don't say the next part. But yeah, is it that?
And I'm not going to lead it there. You've started out beautifully. I was about to say that sound like you eat chicken and rice today, but continue, man. Say, it is that number that what?
So it is a number that divides through another number. And 0 can leave. Nothing. 0. I don't know how to put that part there.
Without leaving a remainder.
But them just say you cannot say that because 0,
The remainder would be
a remainder of 0. Yeah. Yeah.
Okay. What about say exactly? What about the word exactly?
Yeah, that
Or
can work
even.
because a number can divide through another number exactly.
Okay, all right, fine, very good. Matthew, I hope you hear what them saying now. Don't say don't 0. Remember, we did factor remainder theorem. I spoke about not saying it don't need a remainder. We can't do that. Okay, very good. Give me an example now, Natty. You're
So
correct.
a factor of 9 is 3.
A factor of 9 is 3. Give me another factor of 9.
1.
1.
Give me another factor of 9.
9.
9.
Okay, very good. So you recognize that that number is a factor of itself, don't it?
Yes, sir.
Okay, very good. All right. So a factor of a number is that number that divides exactly into another number. True or false?
True.
True.
All right, very good, excellent. I guess the trouble start now. What is a multiple?
I don't know how to put it together, but like I know that so I'm not even if right, but I think me right like 20 is a multiple of 5.
How you know that?
So me know
Because 5 can go into 20.
whatever.
That's all? That's the reason, you know?
Without leaving a remainder.
And so it's only 5 alone can go into 20?
No,
sir,
sir. You have other number too, sir.
4.
10, 2, all of them there. 1, 20, 2, 10, 5, 4.
Okay, so 5 is sorry, 20 is a multiple of 5 because 5 times 4 equals 20. Talk truth.
Yes, sir.
Yeah, man. So a multiple of a number is when you have factors multiplying together to give you that number. So it's a product of two numbers to give you that number. So a multiple of a number, and I mean, you see the definitions. I'm not giving you no online definition or no text definition. I'm explaining this stuff to you. So if they ask me what is a multiple of a number, it is product A times B results in C. C is a multiple of A and B. So a multiple of a number occurs when two numbers multiply together to give you that product. The product is going to be the multiple. So it beautifully said, Natty B, Kessie, I heard when he came in. I love what it also said, Kessie, very nice. But there's something though that is unsettling to me. And let me see if you guys catch it. 3 is what of 9?
A factor.
A factor.
5 is what of 20?
A multiple.
5 is what of 20?
A factor.
A factor. 6 is what of 36?
A factor.
10 is what of 100?
A factor.
Factor.
12 is what of 3?
A
Repeat, sir.
multiple.
Multiple.
36 is what of 1?
A multiple. Multiple.
Multiple.
4 is what of 2?
Multiple.
Multiple.
Okay. What conclusion can be drawn now?
Sir, is it that the smaller numbers are factors and the bigger numbers are multiples?
Excellent. Very good. So the smaller number into the bigger number is a factor of the number, and the bigger number to the smaller number is a multiple of a number, right? So you can't ever say 10 is a factor of 5. So the smaller to the bigger is factor, the bigger to smaller is multiple. So 5 is a factor of 10, but 10 is a multiple of 5. So how I'm giving you this stuff, I can't talk to you about them in isolation. I have to speak to you about them in unison, together, because factors and multiples go together. In order for me to describe, I notice I never talk about a multiple first. I had to speak about a factor first, because in order for me to describe a multiple, somehow in that conversation, the word factor must come into play. So which is why I say to Tanya, how you going to define a whole number for me? I use integer. I don't even know what an integer is. Because we have not yet defined an integer, so we need to go back to whole numbers and integers. All right. So I could not define multiples first, because any definition at all you see about multiples, it must either imply or include the word factor. Because how it is that we get a multiple is by multiplying two factors of a number. to give it a multiple. So 20 is a multiple of 5. It is also a multiple of 4. Because the two numbers that are the other number that I multiply with by 5 to give me 20 has to be 4. So I can't just speak of that of a multiple without making reference to the factor. So the smaller into the bigger is a factor. The bigger to smaller is a multiple. Just remember that. And hence we speak about the lowest common multiple and the highest common factor. I'm going to do it. Forgive me. I'm going to do it, and I want you to think about it. Lowest common multiple. LCM. We all learned about LCM when we went to local schools. Some teachers teach it beautifully. Some teachers make a mess at it. Lowest common multiple. Why do they call it lowest common multiple? Why do we never talk about the highest common multiple? Can you speak about the highest common multiple?
No.
Why?
Sorry, this is a trick.
No, I just want to see if you guys are thinking, why can't we speak of a highest common multiple?
Because the multiple are the bigger number.
Like seriously, Julia?
We don't know what to say.
That's exactly
Yeah,
what I
always
was
get a
going to
higher
say. That's why I
multiple.
never answer. Because I was going to say something like that.
Matthew, what is it, Papa? Oh, sorry, Tyreek, what is it?
So it will be infinite. You can.
Thank you very much, Tyreek, for using a
Sir,
big
you
word.
never hear me, sir.
Tatiana, I truly love you, know. It will untreats. All right, very good, Tatiana, very good. You must talk up louder, TT, right? Very nice. It is going to be infinite. I can't speak of the highest common multiple. It never ending, right? So guess what? We speak up of the lowest common multiple. Why do we speak about the highest common factor? And not the lowest common factor, for argument's sake. Somebody, anybody. Why do we speak about the highest common factor and not the lowest common factor?
Repeat, sir.
Why do we speak about the highest common factor and not the lowest common factor? Tanil, I know you don't want to answer me because, answer me, Tanil. Why do we speak about the highest common factor and not the lowest common factor? Hello, somebody?
Sir, because that's where the limit is. You could always get a lower factor.
Could they always get a lower factor? Okay,
Or,
what is?
sir, a low number is a factor because factors are small numbers.
Okay. You notice what I said? You know what it is? I said highest, and then I'm asking you to compare with the lowest. What is the lowest common factor of a number?
1.
Thank you, Tyreek. Is only Tyreek alone eat breakfast this morning? I did say to you that the factor 1 is a factor of all the numbers. So I already know what the lowest common factor is. I don't need to know what the lowest common factor is. It's a given that the lowest common factor is 1, numero uno. So that's why we speak of the highest common factor. That's why we speak of the highest common factor. Are you following me?
Yes, sir.
Making any sense?
Yeah. Yep.
Yes, sir.
Yes.
No. All right, cool. I'm happy. All right. Hmm. What is the highest common factor between 4 and 12?
4.
Huh? Listen to me. I'm gonna do let me laugh tonight, you know. What is the highest?
4 and 12.
Yes, please.
4.
4.
2, sir.
Hey, don't funny.
Sir, 12.
No 4, sir.
Yeah, can you repeat the question, please?
What's the highest common factor between 4 and 12?
4.
Sir, just stay with the answer. Now, sir.
3.
A 4, a 4.
Or
The answer is 4. The answer is 4, yeah. What is the lowest common multiple between 4 and 12?
12.
Okay. Very nice. Yeah, 12. It is 12. It is 12. Very good. So you guys understand that. I know, to be honest with you, now that I'm thinking about it, maybe that's why what? No, sir. Maybe that's why fractions are so poorly understood and done by students because of the struggle with number theory. The struggle with number theory. All right. So let me take this number. All right. So look at odd, look at even, look at prime, composite factors, multiples. What are counting numbers? What are counting numbers? Hmm?
All numbers.
Yes, I am. What are natural numbers?
Counting numbers.
Very good. Thanks for that. Natural numbers are counting numbers. What are counting numbers?
Natural numbers.
If I clap you see, so you're cute.
Is that when you start at 1 or at 0?
Oh, you tell me no. Me
It's
want to get a bank
Sir,
word.
when you start
One.
at 1, sir.
1.
You start at 1 or 0. Which one?
1.
1.
Yeah, and very important. Very, very, very important. So natural numbers are counting numbers. But what are counting numbers? Counting numbers are those numbers starting from 1, 2, 3, 4, and it galang, 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 and
Sir,
galang.
infinite.
Very good. Very good. Excellent. What are whole numbers?
Them start from 0.
So when you start at 0.
Very good. Cassie? Unmute for me,
Yes,
please.
sir.
What happened? What specific? What special happened today?
Nothing, sir. Why you ask?
You turn up tonight, man. You swag book. I like it. You ask me if I give an extra piece of chicken tonight here. Very nice. Here goes a trouble question. Having discussed correctly a natural number, a counting number, and a whole number, what are integers?
Sir, all numbers. Remember.
What do you mean by all numbers?
So it include natural and counting.
Okay. Give me examples.
So 0, 1, -1, no.
Okay, very good. That is what I wanted to hear, Mr. Neil. It's not just negative numbers and positive numbers, it also includes 0.
Sorry, I never said that.
You said positive numbers. You said negative numbers.
I did.
Yes, miss. And I am waiting for the 0, and I didn't hear the 0, and that's why I said I'm coming back to it. You never hear when I say I'm coming back to you with the whole the integer sentence.
No, sir said something about fraction. I never said any negative or positive.
Well, if it's not you, somebody say it then. And that's why I say I'm going to come back to the integers. So integer. So when you speak of an integer, think of the number line. One side again have negative, the other side again have positive, separated by 0. So the number line is an indication of an integer. Negative numbers, positive numbers, including 0. Including 0. Now let me just tell you what can happen. Oh, but then again, no, let me say now, get that. Say for example, if you are getting a question, a multiple choice question on numbers, then could ask you, all of the following are integers except, and then he's only for something, you have to look and say, oh, which is which? All of the above, but something missing. So when you speak of an integer, you're speaking of a positive number, a negative number, including 0. Picture this. Picture this. Imagine a number line in your headspace. Imagine a number line. Imagine a number line. Imagine a number line. Everybody imagine in a number line?
Yes, sir.
All right, good. And atop the number line from 0 going to the right is which set of numbers?
Positive.
Starting from 0, go to the right. Which set of numbers we're talking about?
So counting numbers.
No, ma'am.
Negative.
Tantan, what is wrong
Positive
with?
integers.
Sir,
No, no, listen to my
sir,
instruction.
which number? With the
May I
cross,
start from
or
may I start from 0? 0. May I start from 0? So 0, I may move into the right direction. Which set of numbers?
Whole numbers?
Thank you. They are whole numbers. Picture this. Starting from 1 to the right, which numbers we're talking about? From 1.
counting.
Very good. Counting or natural numbers. Counting or natural numbers. Everybody see that?
Yes, sir.
All right. Right. So when you look at your set of integers contains your whole numbers from 0 go along to the right. It also contains your counting number or your natural number starting from 1 all the way down to the right. What else does it include? Does it include your even numbers?
Yes, sir.
Yes.
Does it include your odd numbers?
Yes, sir.
Does it include your prime numbers?
Sir, it does all of them.
Absolutely it does. Absolutely. Absolutely. All right. Now, let me just create something here for you. Even though sets is not on your timetable, rubbishness on your syllabus. Can an even number be a prime number?
Yeah, 2.
Okay, very good. Can an even number be a factor?
Yes. 2.
And a multiple?
Yeah.
A whole number, an integer counting number, a composite number? Can
Yes.
two be a,
Yes,
can two be a composite number?
No, sir. Composite number have more than 2 factors.
Very good. So can it be an odd number?
No.
no.
Okay,
Going to leave and read that one.
very good. So so when you look at an even number, for example, 2 cannot be odd. It is prime. Cannot be composite. It can be a factor, it can be a multiple, it can be a whole number, it can be a counting number or a natural number. All right. Let us look at the number 4. 4 is even. Can it be odd?
No.
No.
Can it be prime?
No.
No. Is it
But
composite?
it's composite.
Can it be a factor? Say
No,
yes.
it's a
It can be a factor. So 4 is a factor.
Yes.
4 is a factor of 16, and 4 is a factor of 20.
Oh,
Talk true.
yeah, okay.
Yeah,
Yes,
yeah,
sir.
yeah. Can it be a multiple? Say yes. A multiple
Yes.
of 2.
Yeah.
Yes.
Multiple of 2 and a multiple
Yes,
of
sir.
1. Yeah, man. Can it be whole?
Yes, sir.
Yes.
Can it be integer? Can it be counting?
Yes, sir.
Yes.
Yes,
Right.
sir.
So what's the point I'm trying to get at? So when you look at a number is not to be seen in isolation. A number can have several definitions. What do you mean by several definitions? Okay, let us take the number 5. 5 is not even, but it is odd. It is also prime. It is not composite, but it can be a factor. 5 is also a multiple. What is a multiple of 5?
25.
20.
5 is a multiple of what?
Repeat,
1.
sir.
5 is a multiple of what?
1.
Itself and 1.
5 is a multiple of what?
1.
5.
5.
5 and 1. No, not 1, just 5.
5.
Sir, get kicked out.
And students?
Here, sir.
All right, so I got bumped off. All right, guysy. I are back. I are back for now. Are you hearing me?
Yes, sir.
Yes, sir.
Yes, sir.
Mhm. Why, man, tell you. Those internet cuts want to dust. All right. Sorry about the breaking transmission, yeah? Boy. So I was saying to you that I streamed about a 3-hour meeting yesterday on my cell phone. So clearly that also drained my Zoom link. I think I have just enough to send WhatsApp messages. I'm sure I can't watch a video or anything on the phone or TikTok or anything like that. The struggles, Jesus. But anyhow, we're together again. Where we again? What were we discussing before we left out?
So you asked if 5 and 1.
Okay, thank you, Papa. So I'm asking you, is 5 a multiple of a number? Is 5 a multiple? Is
Yes,
5 a
sir.
multiple?
Yes, sir.
Multiple of what?
1.
Very good.
Sir.
Very good. Very good. Very good. So, and it's a whole number, it's an integer, it's also a counting number. So the point I was trying to make there is that all these numbers are interrelated. They have relations. Some of them is a distant cousin. Like 5 can be an even number. So nobody even number, but it just can be. It just can be. I mean, 5 is not an even. 5 is not an even number, but guess what? 5 is a number that is related to an even number. Rubbish. Yeah, that is related to an even number. So 5 knows about 2. Rubbish. 5 knows about even numbers, but there are no relations. They are friends because they sit on the same number line. They have, matter of fact, they have relation, you know. Yeah, man, they have relationship because
So
they are part of the counting
25.
number. No, they are counting number. Yeah, man, they are counting number together, a natural number together. Because remember, 2 and 1 can't be natural number, you know, it's all of them. So 2 and 5 related, not in all sense, but you know, them have some distant relation. You know, them are counting number and a natural number, and them are whole number, and them are integer. Them are multiple, them are factor, them prime, but them just not composite and odd. And even, sorry. But anyhow, so them have relation. What's the point I'm making? Is that all these numbers are related. So no number stands alone. That's the point I'm making. No number stands alone. So if it, well, one is like cell phone, because some people have multiple cell phones walking with. Everybody have at least one cell phone. Some people have multiple cell phones. All right, so one is in everything. That's where what is not even, you agree. But it is odd. It's not prime, it's not composite, but it's a factors of multiples, whole, it's an integer, it's a counting number. So when we talk about the real number system, and we talk about those numbers that are irrational, those rational numbers are the numbers that we have there listed. Let us take a look at those numbers that are irrational now. Irrational numbers, and I can't write it, I can only tell you. What's your irrational numbers? Are numbers that cannot be written in the form A over B, where A and B are members of a set of real numbers, and B is not equal to 0. Let me see if I can type what I just wrote, what I just said. Let me see if I can do that now, because if I could do that, I could have switched to this.
So you say 5 is a prime number, right?
5 is not 5 is a prime number. 5 is a prime number? No.
Yes.
Yes, it is a prime number. It's not a composite number, it's a prime number. How do I do this? How do you think I do this now, guys? How do I import? Me no more to go insert. How do I import? Oh, I say export. You know what export? I export more export, you know. You need to export it to a document, import it and I'm carrying it in. So we export to Office, Office mode, you know. JPEG, PDF, PNG file, Rockstone, JPEG is in that picture, PDF. All right, let me try the PDF because I can convert the PDF. We don't know. Ain't doing none of that. I'm not creating no account. Ah, come on. Sign up with your Google account. I don't want to do that because I don't suspect that I'm coming back to you, Smart Draw. Okay, so after being sitting and figure out all of them something, I mean, tonight's classes don't want me to be great. Look, I'm to do something neat and nice. And now the man them tell me to can insert it into my document. Export as text file. Alright, is it asking me to create a thing? Alright, I may consider creating a document. I may consider. Let me just do a new share. Alright, so irrational numbers, I-R-R-A-T-I-O-N. So irrational numbers are those numbers that cannot be written. And irrational numbers are numbers that cannot be written in the form A over B, where A and B where A and B are members of the real number system. And B is not equal to 0. Oh my Lord. All right. So what I'm saying to you is that irrational numbers are numbers that cannot be written in the form A over B, where A and B are members of the real number system, and B not equal to 0. What do you mean, sir? You see, when you can't write the number as a fraction, the number is termed irrational. Once the number cannot be written as a fraction, the number is termed irrational. For example, pi. Pi is irrational because it cannot be written as a fraction. Do you agree with that?
Yes.
Yes, sir.
Do you all agree with that?
Yes.
Okay. When you're going to school, let me see how your teacher told you. Did they ever say to you that pi is equals to 22 over 7?
Oh, yes, sir.
Yes, sir.
Yes, sir.
Tell me exactly what the teacher said to you.
No, sir.
She
What the
said
teacher
can
said.
be written as a fraction or a
Sir,
decimal.
I'm not here. Wait, pi is 24 over 30.
See that buckle boy say with the honey bunches? Where's it?
Sir, I'm gonna say my ear and say pi is 24 over 30.
This is the lie. What I want to get from you is what did your teacher say to you? I want to see if you can remember the exact wording. What your teacher said. Did your teacher say to you that pi is 22 over 7, can be written as 22 over 7, is approximated to be 22 over 7, or just 22 over 7? What is it?
She said it can be 22 over 7 or 3.14.
Or 3.14. Okay. You did say she. So did she derive pi for you? You know
Remember,
what?
the pi is this.
No, sir, she just said us, sir.
What?
Sir, look how long that's, sir.
Sir, is it safe to say pi is 3 and 1 over 7?
Same difference, 22 over 7. All right. This is where I have my greatest concern. When I never get the chance to become a medical doctor, I said I wanted to become a teacher of teachers. I wanted to teach teachers how to teach. And this is one of the areas that you don't just tell students that pi is 22 over 7 because pi is not 22 over 7. Pi can be approximated to be 22 over 7. And there's an easy way to demonstrate it through the introduction of geometry. So when I used to teach into the high school system, and I get a 12 from class to teach, and we introducing geometry, best believe say, but I have to go a class with the circle cut up. Because how we learn mathematics in Jamaica is, you have to show me so I can believe you. You can't tell me nothing, you have to show me it. So I should go to the circle and show the students them, and them say, oh yes, sir. So to the point where you go into an exam, what CXC says, use pi as 22 over 7 for ease of calculation. Use pi as 22. And sometimes they say to you, use pi as 3.14. And then some other time you say them say use pi as 3.142. So anything them tell you to use pi as, use it as it. Say them say use pi as 22 over 7. Don't be bright and use it as 3.14. So you're going to end up with decimal in an answer and demand them if they use it as 22 over 7, you're going to end up with a fraction or a whole number. Right? So pi is an irrational number. You can't represent pi as a fraction. You can only approximate it as 22 over 7. You can only approximate it as 22 over 7. Those numbers that are also irrational are numbers that are recurring. Recurring numbers are also termed as irrational numbers. For example, 1 over 9, 0.11111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111 All right, so for example, 1/9, which is 0.111. Normally when we have a recurring decimal, we put a dot over the last digit. And we can also oh, come on. 1/3 is another example.
Sir, why not just put ellipses?
Why not just put a who?
Ellipses.
Or I could put it as a point or a dash. So I can either put a dot over the last digit or a dash.
Sir, hyphen.
A hyphen. You are correct. A hyphen. Yes, you are correct. I won't even justify it. You know, sometimes we speak. I hope I never hear you say a running belly. You know, right? Because and you use the correct terminology all the time is tantan, but yes, a hyphen. Right, so I can put a dot or a hyphen just to show that the number recurs, right? So recurring numbers are also numbers that are termed irrational. Those that are terminating are not, like 1/2. Yeah. So you don't have many of those irrational numbers. Well, let me not say it like that. So every number in the real number system can be termed either rational or irrational. Every number in the real number system can be termed rational or irrational. All right. So one broad sense is that once it cannot be written in the form A over B, where A or B are members of a set of real numbers, and B not equal to 0, it is going to be irrational. Those that are recurring are also irrational, right? Some say the terminating ones are also irrational too, but you know, whatever. So those are they. Those are they. Any questions so far? Talk to me.
No.
No, sir.
All right. All right. Let me jump to something else. All right. All right. So terminating decimal is also rational, right? It's also the recurring one that are irrational. Terminating decimal is a rational number. So let me put that there for Like 5 over 10 is going to be 0.5. Terminating means that you don't have any other digit. It ends, it does not continue, right? So like, 3 over 8 or whatever those numbers are. So yeah, so that's what the real number system looks like. I did ask if you understand and you did say yes. So I need to include my lovely drawing that I thought I could have superimposed. Insert DRAWING. All right. It wants me to talk to you about complex numbers. I don't think we need to do. All right. Let me do this part first, and then we'll do the complex numbers after. All right. So we need to solve equations, quadratic equations where the discriminant is negative. We need to solve quadratic equations where the discriminant is negative. Was it this class? I'm trying to remember. If recently we're doing something and somebody asked about the quadratic formula, I think it was this class, and I was doing something with them, and somebody said, "Sir, we could use a quadratic formula." And then I did write the quadratic formula, and for you, x is equals to plus or minus b, minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When I'm solving a quadratic equation, I can either use factorization by grouping. I could also use completing the squares. I could use a graphical approach as also the quadratic formula. The quadratic formula is very useful, extremely useful. And especially now that we are going to be using it to solve equations where the discriminant is negative. So it says, let's just look at an example there, where it says x squared plus 6x plus 15 is equal to 0. Using the quadratic formula, we know that the coefficient of a is going to be the coefficient, yeah, I'm correct. The coefficient of the x squared term is a. The coefficient of the x term is denoted b, and the constant term is denoted c. Everybody knew that, right?
Yes, sir.
So the coefficient of x squared in this particular case is 1, so that's why a is 1. The coefficient of x is positive 6, that's why b is 6. And the constant term is 15, that's why c is 15. The discriminant is b squared minus 4 times a times c. The discriminant is b squared minus 4 times a times c. The discriminant is 4 times a. All right, so I want you to recall the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The discriminant is going to be what is under the square root sign. B squared minus 4 times a times c. See here? The discriminant is b squared minus 4 times a times c. All right? That's what the discriminant is. Now, why is it called the discriminant? We know that we can't take the square root of a negative number. We can't take the square root of a negative number. So it's called the discriminant because when we take the square root of a negative number, or when we get a number to take the square root of, and if it is negative, then we are in trouble. We are in trouble. If you put negative 2 on the calculator, if you put negative 4 on the calculator, it can't work. There is no way it can work it. You understand? But if you have a good calculator like me, it'll work it. And give an answer. as 2i. Watch me. So this is the discriminant. The discriminant says that if I want to know if something is solvable, we can check the discriminant. If the discriminant is negative, trouble. If the discriminant is positive, smooth sailing. Chicken and rice, smooth sailing. But if the discriminant is negative, fried fish, you have only a bone, can't eat it fast, you will choke. All right, let's go. So remember, the discriminant is b squared minus 4 times a times c. So where do we get that from? The quadratic formula. The quadratic formula is x equals minus b plus or minus the square root of b squared times 4 times a times c all over 2 times a. All over 2 times a. So that's what I'm saying to you. So I have that beautiful formula. And incidentally, if I were, the quadratic formula is actually derived from completing the squares. The quadratic formula is derived from completing the squares. And it's a beautiful derivation. Normally when I'm teaching system mathematics, I show the students how to do it. It's not on your syllabus to prove because it's already on the CXC syllabus. So once the students would have come through my hands for CXC math, they would know how to do all of that. So when they come to Cape math now or integrated math, they come in that knowledge. All right, let's go. B is 6. So it becomes 6 squared minus 4 times a, which is 1, times c, which is 15. See it right here, so? Six is 36. Negative 4 times 1 is negative 4. And negative 4 times 15 is going to be negative 60. 36 minus 60 is negative 24. Is negative 24. A question such as this, you say has no real factors. Has no real factors. Watch me. Inserts this negative 24 is going to be written as negative 4 times 6 times negative 1. This 4 can be broken up into the root of 4 times the root of 6 times the root of 1. So once I have anything, any number at all under the square root sign, I can then separate them as multiples. So this is going to be the root of 4 times the root of 6 times the root of 1 of negative 1. The root of 4 is going to be 2. The root of 6 is as is because I can't take it. And the root of negative 1 is as is. Well, actually, the root of negative 1 is going to be I. So when you find the square root of negative 1, you're going to get I. Right? So what I'm going to get is 2 root 6 times I, which is going to be my complex root. So it says since there are no real values, real roots, we have to find a complex solution. No real roots, I have to find a complex solution. So when you put it like this now, this is going to give you the complex solution. Now, this complex solution has a real part and an imaginary part to it. This is the real part of it, of the complex number, and this part is the imaginary part. Any part with the I is going to be the imaginary part. Right? So this is 2 root 6 I. I is the square root of -1. So remember, sir says to you, at this level, you can't take the square root of a negative number. But now that you're doing integrated math, yes, you can. Because the square root, for example, of -24 is going to be 2 root 6 I. When you see the I, the common I, not capital, but the common I, says to us that we have a complex root. Complex root. So when we try to solve, this is what we're going to get. Minus b, which is -6, plus or minus. The discriminant is going to give me 2 root 6i. See here, 2 root 6i. So I'm going to have -6 plus or minus 2 root 6i over 2. This 2 here is governing things up here. So let me put another line right there. Copy. All right, so this is what is happening here. I am factoring out a 2 from the numerator. I'm factoring out a 2 from the numerator. So because I factor out the 2 from the numerator here, I'm going to have -3 plus the root of 6i left. And when I divide both sides by 2, I'm going to end up with -3 plus or minus 6 root 6 of I, which is my complex root. This part here is the real part. This part here is the imaginary part. Any questions to that? Yes or no? Shoot them. Any questions?
No, sir.
All right. I had done this for you, but I didn't start here. Let me just run through all of this here with you because it's important. So the numbers, something to finish, right? In another couple of minutes, I'm finished with this. So I was doing some prerequisite knowledge. I remember some time ago in class, I think I asked some question, and if my memory serves me right, I think Tyrick was able to write it in third form. Is that true, Tyrick? I'm just trying to remember. Anyway, I don't remember what I was doing exactly, but I remember giving something in third form at one point in time, and I remember him being able to carry it on into the simplest part. Let me just tell you something. For the life of me, when I was going to school, I just couldn't understand what this third business is all about. I used to hate it. I remember one day we got a math test. What was it? It was additional math class. We got a math test and the teacher give back everybody them paper and I wonder how me not give back my paper. Not give back my paper. I said, no, that's what I'm going in the class, miss. And the teacher said, well, congratulations, you got 96%. And I said, damn, I couldn't get 100, man. You know, of course, we are losing 4 points, thirds. So, you know, I had this sort of love-hate relationship with thirds because thirds just never wanted me to be great to get the 100%. Got 96 because of this third percent. So I just used to hate it. And then years later, I sat down and I said to myself, what is this about thirds that I didn't like? And I said to myself, Eureka, I found it. I found what was the difficulty, and I'm going to show you what was my difficulty. When I get there, I'll tell you. So when you talk about how it is that those guys back then in the day used to say, boy, the square root of 100 is equal to 10. What they are doing is they are saying that the root of 100 is 10 squares, and 10 squares is equal to 10. Why, sir? Because we can look back at the nth root law that we did in indices. The nth root law that we did in indices. And remember, whenever we have a square root sign, it says that it is raised to the 1/2 power. Anybody remember that? When you have a square root sign, it's raised to the 1/2. Right. So this 10 squares is going to actually raise to the 1/2 power. And the law says from indices that when you have a power raised to another power, you are going to be multiplying both powers. All right. So see here now we can multiply this 2 by 1/2 and 2 halves make a whole. And 10 to the first power is going to be equal to 10. So that's how the man they get the whole business of the root of 100 to be equal to 10, just by using indices. Just by using indices, all right? So from this, we can see that the square root of a, all squares, is going to be equal to a. The root of ab is the same thing as the root of a times the root of b, which is what I was showing you all the way down here, right here. So the root of 4 times 6 times -1 is going to be the root of 4 times the root of 6 times the root of -1. All right. So that's why I'm doing the prerequisite knowledge so that you can see all of what is happening. So the root of ab is the same thing as the root of a times the root of b. The root of a divided by b is the same thing as the root of a divided by the root of b right here. So look at these 3 laws for me in another minute and try to digest it. Look at those 3 laws in another minute and try to digest it for me. All right, so just remember that when you're multiplying, the root of whatsoever is under the square root sign, you can break them apart by multiplying. Whatever operation is being done under the square root sign is the same operation that you'll do when you separate them. A is being multiplied by b, the root of a times the root of b. A is being divided by b is the root of a divided by the root of b. So it works from the left to the right. It also works from the right to the left. So if I have the root of a divided by the root of b, I can simplify it as the root of a divided by b. All right, let's just get some examples. And I'm going to use this very simple example to explain what difficulty I was having. So, me just have a problem. How to know that the square root of 8 is going to be equal to 2 root 2? I just don't know how to get it. And then I had an aha moment. Look at the aha moment. You see this 8? I'm trying to find factors of the 8 that is, I'm trying to find factors of the 8 that one of them is a perfect squares. That's what I was missing. So I'm trying to find factors of 8 that when multiplied together will give me 8. And I'm trying to find 2 factors of 8 too. Now I'm talking about 3 factors, 2 factors of 8. When multiplied together give me 8, but one of those factors is going to be a perfect squares. Come me always I say, no, 8 times 1. Or try to find some other numbers which just may not work for me. But I'm looking for factors of 8. When multiplied together, one of them is supposed to be a perfect square. So for example, 4 times 2. 4 is a perfect squares. So I'm going to have this 8 being broken up into 4 times 2. Let us try 32. Because 32 you can have 16 times 2. What other number? You can have 4 times 4 times 8.
times 8.
Yeah, you can have 4 times 8 too. You know, yeah. So for me, I just didn't understand what was happening. And I'm going to show you the 4 times 8 with this one. So this one here, I'm going to put it at 16 times 2. And 18 is going to be 9 times 2. So why using 9 times 2? I'm using 9 times 2 because, of course, 9 times 2 is 18. And I could use 6 times 3. 6 times 3 is 18 to don't.
Yes, sir.
But neither 6 nor 3 is a perfect squares. So when I was going to school, they said, why can't you use 6 and 3? And then it used to just frustrate me. I was so frustrated with it because I don't know if I was sleeping or I didn't miss that class or something went wrong, but I just couldn't figure it out. So I'm looking for multiples. I'm looking for factors of the number. That one of the factors must be a perfect square. That's a trick. So I can't use 6 times 3 because neither 6 nor 3 is a perfect square. So I have to use 9 and 2 because 9 is a perfect square. So watch me now. Remember, sir said to you, when you're doing the multiplication under the square root sign, you can separate them and keep the same operation. So this is going to be the root of 4 times the root of 2 plus the root of 16 times the root of 2 minus the root of 9 times the root of 2. Watch this magic now. The root of 4 is 2. See here? The root of 2 is the root of 2 because you're going to get 1.42 te. So let's go right at the root of 2. The root of 16 is 4, so you have 4 root 2. The root of 9 is 3, and the root of 2 is that. So you now have a function in the root of 2. So it's like having 2x plus 4x minus 3x. But it's just that your constant right here is going to be the root of 2. So 2 root 2 plus 4 root 2 is going to be 6 root 2. And 6 root 2 minus 3 root 2 is equal to 3 root 2. So all of them ugly number here, when you add up and subtract together, your final answer, when you simplify it, will give you 3 the root of 2. Tell me that is what I'm talking about.
Sorry, can you do about the last line again?
So what I'm saying to the last line is like you having 2x plus 4x minus 3x. And then you can group them together because they're all in x's. In this here, you can group them together because they're all in the root of 2, the root of 2, the root of 2. If one of them was the root of 3 and the root of 4 and the root of 5 or the root of 3, the root of 5, the root of 7, you have to go leave the answer like that because them can't be combined. But the mere fact that they have the same, the root of, you can combine them because they are related. So 2, the root of 2 plus 4, the root of 2 is going to be equal to 6, the root of 2. 6 the root of 2 minus 3 the root of 2 is going to be equal to 3 the root of 2. All right? Let us look at this other example. You may be able to see it a little better. I'm saying the root of 8 plus the root of 18 minus 2 the root of 2. But sir, we know there's something similar to that up top. Yeah, very nice. So you know the root of 8 is going to be 4 root 2. And you know the root of 18 is going to be 9 times root of 2. And this can't be broken down into anything simpler because it is already simplified. So you're just going to write 2 the root of 2. Bam. Again, 4 the root of 2 times 2 the root of 2. Rubbishness. Scratch that. The root of 4 times 2 is going to be the root of 4 times the root of 2. See it right here, so. 9 times the root of 9 times 2 is going to be the root of 9 times the root of 2. See it right here, so. And this is putting it back because that is already simplified. The root of 4 is 2. The root of 9 is 3. And again, all of these are in the root of 2. So you can combine them. Negative 2, the root of 2 plus 2, the root of 2 cancels out. So all I'm left with is 3 the root of 2. So there's just some basic algebra using surds. It follows the same rules as you were using, you're doing in algebra. The same rules. You add like terms together, unlike terms can't be added. All right, same rules. All right, let's just look at another one. Let's just look at this multiplication. Oh Lord, I did this multiplication without even showing the steps. All right, let us distribute this one. This 3 plus the root of 2 over 2 plus the root of 2. Let us do the distribution. We're foiling first, outer, inner, last. First, outer, inner, last. What do you mean? Gabby Thomas beat Sherika Jackson? Oh, I want to Sherika. She don't know so she's Jamaican and that the US them supposed to win them. Clearly she don't get the message. No, I forgot to give her a talk. Alright, let's go. 3 times 2 is 6. Copy. So 3 times 2 is 6. Work with me now. This 3 times this 2 is 6. This 3 times 2 root 2 is going to be 6 root 2. Talk truth.
Yes, sir.
Yes, sir.
And then the root of 2 times 2 is going to be 2 root 2.
Yes, sir.
Good job, good job, good job. And then now, oh Lord, the root of 2 times 2 the root of 2. Oh no. Oh no.
Sir, is it 2 root 4 or just 2 root 2?
Ah, 2 root 4. But root 4 is going to be what?
2,
And then 2 times 2 is?
4.
I'm happy you said it, because I mean, I was wondering how it is that I was going to explain it. You hear what Tani said a while ago? This, the root of 2 times 2 the root of 2 is going to be 2 the root of 4. Because remember I said to you, when you're multiplying 2, the root of 2 times the root of 2, you can put them two under one, we call it, square root sign. So we have 2 times 2 is 4. And then we end up with the root of 4, and the root of 4 is 2. And 2 times 2 is going to be equal to 4. The 4 right here, so. You're very nice. So 6 plus this 4 gives me this 10. And 6 the root of 2 plus 2 the root of 2 is going to be 8 the root of 2. And that's my answer. Any question?
No, sir.
All right. I want you to try that for me, please. I give it 2 minutes. Let me know when you finish.
So I'm telling you the honest truth, I never really understand it.
All right. Now 2 to the root of 4. All right, see turn on purple. So I'm going to have the root of 2 times 2 to the root of 2 is going to be this 2 times the root of 2 times the root of 2 is the root of 4. All right, but the root of 4 is going to be equal to 2, and 2 times this 2 is 4. Tell me that you see it now, Matthew.
Let me say again.
Say it again, Papa.
I can repeat what you just said.
All right, so I'm saying to you, this root of 2 times 2 the root of 2 is going to give me 2 times the root of 4, because the root of 2 times the root of 2 is equal to the root of 4. But the root of 4, you know, is 2, and 2 times 2 is 4.
Oh, I get it now.
Nice. All right, what did I ask you to do? Okay, so I get 6 the root of 3 for my answer. Everybody got that? Anybody got that?
Yes, sir.
Nice. So some people may be
Sorry, I
struggling.
gotta go through it, right, sir? Because I don't know the beginning. I don't even know where to start, sir.
All right, so what we're going to be looking at is the root of 75. So remember, I need to find two numbers. I need to find two factors of 75. When multiplied together will give me 75, but one of those numbers must be a perfect square. So the numbers that I'm going to think of is 25 and 3, don't?
Yes, sir.
Right, copy, all copy. So I'm going to think of 25 and 3. Paste. So it's going to be 25 times 3. And then 12 now is going to be 4 times 3. Talk truth.
Yes, sir.
And 27 is going to be 9 times 3. Now, if you want to find one of them, chances are you'll find the others, because it just almost follows a sequence, especially if they're asking you to add some stuff. They're not going to give it to you weird out that you can add together. But they're not trying to frustrate you in the exam, believe it or not. They're trying to see if it is that you can manipulate the the operations of the search. All right, let's go. Casey, are you with me?
Yes, sir.
All right, so this 75, I'm writing 75 as 25 times 3. 25 times 3, 75. I have 3 25 cents, I have 75 cents. Why I use 25, sir? Because 25 is a perfect squares. All right. 12 can be written as 6 times 2, but neither 6 nor 2 is a perfect square. So I'm going to try the other double factors of 12, which is going to be 4 and 3. Yes, sir, 4 is a perfect square, so I can use 4. All right. So that's why I write 12 as 4 times 3. That's what I was missing when I was going to little school. Don't want you to miss it. So I'm telling you my secrets. And my secret stays right here, so nobody else seems to know it. Right? But I don't have enough time for you to explore, and I don't want you to be frustrated. So that's why I'm telling you what I struggled with, so that you don't have to struggle with it. 27 is 9 times 3. Why 9 times 3? Because 9 is a perfect square. 3 isn't. But if you look at it, you recognize that what is common here is 3. Copy. So I'm going to have now the root of 25 times the root of 3 plus 2 times the root of 4 times the root of 3 minus 9 times, sorry, minus the root of 9 times the root of 3.
Sir, one question. Sir, like I have the 2 outside, where the sleeve of the square root sign is, you'd multiply it. You multiply by the number under the square root. That's what you do. That's what you're supposed to do.
This two right here, say talking?
Yes, sir.
No, this is a whole number 2. I can't multiply it inside this. Is a whole number 2. Why do I have this at the same time? I can't do that. It's a whole number 2.
Sir, not multiply, I mean add.
No, you get to multiply. You see what I'm talking about. So in this case, no, Tani, because remember this 2 is being multiplied by this root of 4 is being multiplied by the root of 3. So you're not going to add it, you're going to be multiplying right here. Because what you have happening here is that this 2 is being multiplied by the root of 4 times the root of 3. So this 2 is this 2. That 2 is that 2. Those 2 are the same. This, the root of 4, is going to give me this other 2. And then this 2 times 2 is going to give me 4. In the interest of time, I just write the answer down, but now that I have to do it. So I'm going to end up with 4 the root of 3. So we're going to have 5 the root of 3 plus 4 the root of 3 is 9 the root of 3. And 9 the root of 3 minus 3 the root of 3 is going to give me 6 the root of 3. Casey, look at that, please.
Yes, sir, I understand now.
Thank you, honey. All right. Giving you this other one here.
But sir,
Yes, my love.
you see the answer.
Say it again.
Never mind.
Sir.
Yes,
We do
Papa.
the last right after you do the 25 part. After the
La-
last part line with 25 and 8 we do after that.
Oh, I just said to myself, the square root of 25 is 5.
Yeah.
The root of 3, I carry it back. This 2 is this 2. And the square root of 4 is this 2. And I carry back the root of 3. And the root of 9 is this 3.
Oh,
And I carry back that one.
right.
And then all of this is this. And this 2 times this 2 give me this 4. I carry back the root of 3. I carry back all of this. And 5 plus 4 is 9, minus 3 is 6. And of course, all of them is in the root of 3.
All right.
Good job. All right, try number 5 for me, please. I'm going to give about 2 more. And just show you one quick other calculation, and then we'll just call it a night. You can go sleep and get some rest. I kind of need to do the same thing too. All right, I give you 3 minutes.
Sir,
Yes, my love.
a class tomorrow.
I am going to be meeting with the students tomorrow. Tomorrow with them. Remember I did say to you that I have some little stuff to do with you. Tomorrow with them, I did integration with them the other day. You again saw the integration. Come tomorrow, God's willing, I want to do cost function with them, which is one of the small areas for you. I decided that I'm not going to teach it Monday, Friday, because I'm just going to do it on the Saturday. Send out the recording and everything. Oh, incidentally, I kind of figured out what was wrong with the recordings. I have been sending out the recordings since yesterday. I hope you guys have recognized and I see the recordings. All right, so just check the YouTube channel. The recordings are being posted. I don't finish yet. I have about 3 more weeks in April to do, and then I'm finished. And then now, I'm also going to look again now at the multivariable functions, stationary points of the multivariable function. So it's another opportunity for those of you who did not catch it fully to see it again. So yes, as soon as I get the link, I will send out to you guys. And please, if you can make it, come on out. I want you to come out. I want you guys to be great. I want you guys to do very well. So I'm actually giving you extra help on a Saturday morning. Please and thanks. All right, 3 minutes.
Sir,
Yes, my love.
sir, I got something, but I'm not correct.
What you got for me?
Yes, sir.
4 square root 7.
Say it again.
4 square root 7.
Yes, sir, I got that.
Got that too.
Yes, Sana, come out.
Me too.
Hello, whoa, yeah, man. Yeah, so nice. Matthew, Terry, Johnny, what you get?
Sir, I'm so finished. All
right, give you half a second more.
I get to.
Very nice. Very nice.
Very close, sir.
Listen to me, man. Hey, when I have a good platform to pass this exam, you know. Let me say I have a good platform, I mean, I have a good platform, you know. And I'm going to tell you honestly, where I felt encouraged, one of my heads got the information and sent it off to me, and up to yesterday I was still telling her thank you, because I was actually waiting for CXC to release the topics, because you recognize the situation that we were in, and I am very, very, very happy that, and I call it divine intervention, just depending upon the Lord to direct me as to what to do. And see, we'll cover the topics. We're finishing up our numbers and the little fillers that we're supposed to do. Trust me, I will get a chance to do it by doing the past papers and in the class on Saturday. So we should be good to go. All right, I'm going to give you one more. Very nice, very nice, very nice. I give you one more and then the others you can do for. All right, take your time on it because I just have one other thing to do. Take 15 minutes and then we can end class early. All right, go.
Sir,
Yes, my love.
I get 5 square root 10.
Very nice on the countries. Make sure that you're doing the actual calculation and I'm not punching anything into a calculator.
No, sir, I can
did-
take a picture and show you,
I
sir.
did not say that you're doing it. I'm just making a general statement to say, make sure that we're doing the actual calculation because they can ask you to do the actual calculation. That's all I'm saying. I'm not saying that you're doing it for me. I wouldn't accuse you of doing that.
Sir got us as well.
Very nice. Very nice. Excellent. Jeez on these. Come guys. Sons of mine. Johnny, Matthew.
Sir, I don't
Tyler.
get sir.
Very nice. Very nice sons. Very nice. What do I do with you guys? You guys are doing too well. All right. All right. You can when I give you the handout, you can do the rest. So let's just look at number 10. Number 10 is going to be the last part of what it is that we're supposed to be doing. When it is that it asks us to conjugate the complex number. So it says express this thingy bob 2 over 3 minus the root of 2 in the form, in all of this form. A plus b to root of c, where a, b, and c are rational numbers. All right, where a, b, and c are rational numbers. Now, look at what I'm going to be doing. Times look at what teacher is doing. I am multiplying by the conjugate of it. Pretty much I'm looking at what the denominator is, and the denominator is 3 minus the root of 2. So I'm going to multiply by 3 plus the root of 2. 3 plus the root of 2, but I'm multiplying it by 3 plus the root of 2 in the numerator over 3 plus the root of 2 in the denominator. Tell me what happens when I multiply by 3 plus the root of 2 over 3 plus the root of 2. It's as if I'm multiplying by 1. Very good, Matthew. Very, very, very good. It's as if I multiply by 1. And you all know that 1 is a multiplicative identity. So I'm not changing it. This is like you cooking Saturday morning soup, and you have a pouch where you stuff all the seasoning and the pimento and the garlic inside of it. So when you finish cooking, you just remove that pouch, and you know, so you remove every single thing. One of the worst things for the eye is to take my last sip of my soup, with my nice piece of dumpling, cheese and peas. I mean, I eat it, man, and go crack a pimento in the something. My vex. Good vex. Because I have to spit out my last piece of dumpling. You understand? This is it. I'm multiplying by 1, which is known as the multiplicative identity. Now change it. We now have the pimento left in the something. All right, watch me. 2 times, oh Lord, copy, paste. All right, so I'm just saying this is 2 times all of this up here, so, and then this is 3 minus 2 times 3 plus 2 right here, so now that I have it looking like how I want it, I'm going to do now multiplication. 2 times 3 is going to be equal to 6, I think. I'm going to have 6 over plus 2 root 2. Talk to me if I'm correct. And then 3 times 3 is 9. 9 plus 3 root 2 minus 2 root 3 minus 4 . Tell me if I'm correct, please. 2 times 3 is 6. 2 times the root of 2 is 2 root of 2. 3 times 3 is 9. 3 times the root of 2 is 3 the root of 2. Minus the root of 2 times 3 is negative. Nope. That's supposed to be negative 3 the root of 2, don't? Yep. Supposed to be negative 3 the root of 2. 3 times 3 is 9. 3 times the root of 2 is 3 the root of 2. 3 minus 3 the root of 2. Yeah. Minus the root of 2 times the root of 2 is going to be the root of 4, and the root of 4 is 2. It's the same. 2 times root of 2 is the root of 4, and root of 4 is 2, so it's minus 2. So these two pieces in the middle cancel, so I'm going to have 7 minus 9 minus 2 is 7. So I'm going to have copy, I'm going to have paste. All of this works out to be 7 So all of that now is going to be, all of this now is going to be 6/7 plus 2/7 root of 2. Like 2/7. Why did I get 3/7 for my answer? Something is not right. What am I looking at? It's supposed to be 2, you know? 2 times 3 is 6. 2 times 2 is 2 root 2. So we have 6/7 plus 2/7 root 2, which is supposed to be 2/7. And not 3. All right, can you just double check that with me for me, please, and tell me if I am correct? Are you hearing me, guys?
Yes, sir.
Yes, sir.
All right. Just double check this for me, please, and tell me if I'm. I had 3/7 right here. Just double check question for me.
Positive 2 to what is? Plus 3, 12, minus. Oh!
For the oval.
That's right.
Why you startling me? Hello?
Yes, sir, it's okay.
Oh. What about the others? You agree?
So I'm reading a note.
Who said that a while ago?
Me, sir.
What do you mean, no, no, not to be?
So I'm gonna know for the this for true. That's this alone. Me did catch the top part, sir.
Because you know, somebody got just up your and just squeeze it out of you a while ago, you know. All right, let's go, honey.
Okay, sir.
All right. So what I'm saying to you is, let us just go through this one because there's just one other thing for me to do, and then we'll finish for the night and we'll finish off numbers. Yes, honey.
Yeah, I have class next week.
Yeah, man. Listen to me. Let me tell you something. You see, I'm wanting to learn something about Mr. Sean. I didn't have it in your first year. I got it in your second year. But one of the things you can learn about Mr. Sean is that I'm sick. I can draw myself from a class. I draw myself from a class. I remember one year I took some tablets and it just never worked with me, and it gave me some bully power reaction. And the morning I got up and I never felt well, but I know I had a pre-calculus class at 8 o'clock. And the instruction that I got was go straight to the hospital. And I said, hospital? I'm having 8 o'clock class? 8 o'clock to 10 o'clock? We're not going till after 10 o'clock. And funny story, that morning, the day before, it was coming up the time like this, the end of the school year. Matter of fact, it was time like this because it was Labor Day that I had been to York Pharmacy and bought the stuff. And it had a negative reaction to me. And, you know, we just have Labor Day and then we'll go back to school the following day. So I went back to school the following day, and the weekend, the student said to me, sir, final week was before exams, what you want? He said, anything you carry. That's what will kind of happen. He said, all right, sir. Will I carry some rum? He said, yeah, man, one Bacardi and Sprite. No, me can't drink, you know. If me smell the liquor, me pass out, me keel over and drop. And this is our secret. Nobody is to repeat this. If me smell the beer, I keel over. I can't drink to save my life. If you give me a piece of Christmas cake, I ain't have too much rum in there, me start talk secrets. Me hear them start spin over, me start sweat, me start get dizzy, me have to hold on. I am just, me just not have no constitution when it come out to rum. And me go tell the students, say, me want Bacardi and Sprite. Rockstone, boy, carry Bacardi and Sprite come to class. And me say, Jesus, come again, get out of that one here. And I remember I was having my team say, sir, dash with the team. Me say, Lord Jesus, throw the team on me. Me a farm, say me a sit to something, come and no say anyhow. Me sit at something there in the class, on block A upstairs at Express Community College. Is an ambulance that come, me go drop, me go start flutter, me go fraud, and then me go say something wrong with teacher. And I just forms the I'm drinking it and just wet my lips. Jesus, Father, I saw the gates of heaven open up, and then I sat down and I never felt well. Student said to me, sir, what is wrong with you? I said, you know, I'm fine. They said, sir, you're not a normal self. Them said, sir, go on home. And then the student said, sir, is it Bacardi and Sprite? I said, no, man, not the Bacardi and Sprite, man. It's not the Bacardi and Sprite at all. Went to the doctor. And the doctor said, you need to go and take 5 days. I went up for take 5 days, come back to Excel and go finish my rounds for that day and then go home. The point I'm making is, I don't take what it is that I do lightly. If I'm not feeling well, it's not your responsibility. A while ago, you know, upset I was when the internet gone. You know, I have a data package. And I went to look for the stuff and clearly it finished. And the next thing that I was doing, matter of fact, I need to check to see if it's gone on, is to put money on the data package so that I can have my data to have my class. I don't take it lightly. No, I don't. So the same energies that I put into your coming to class and preparing for class, you see, I did not finish the handout. I know what, sir, did? Come to class and finish the handout while I'm teaching you. Yeah, man, I have to do that. So the same energies that I take into preparing for your class and coming to class and circumventing the challenges to make sure that I'm here and rated and so, the same energy I want to use in the preparation and the execution of everything that you have to do in order to pass the course. Trust me, we've not missed a class, thank God, from 25th of October. Yes, we had some internet challenges and we expect to have those challenges. But we're connected every single Monday, Friday. And for the last 2-3 months, we've been putting in some Saturday classes. And we are connecting. So I'm saying to you, the same energy that I put in us, that's something your people, are the same energy we want to put in on it too. All right? So let's go. All right, let me just review this one quickly because I did say to you that I was going to finish at 8:15. It's 17 past. Let's go. This one says, I'm multiplying by the conjugate. Sir, conjugate. Look at it. It's the opposite of this one. So the denominator is 3 minus the root of 2. I'm going to multiply by 3 plus the root of 2. Is that the opposite way? It's like creating the difference of 2 squares. Right? It's like creating the difference of two squares. All right. So when I rearrange it now, and when I multiply by this, 3 plus the root of 2 over 3 plus the root of 2 is as if I'm multiplying by 1. Is as if I'm multiplying by 1. And 1 is known as a multiplicated identity. What do you mean by that, sir? When I multiply 1 by anything, I get back anything.
Sir, why is it multiply by 3 plus the root of 2?
Say it again, Mom.
Why is it that you multiplied by 3 plus the root of 2?
Because that is the opposite to it. That's a conjugate of it.
Oh, okay.
And think of it like the difference of two squares. So I'm multiplying by the opposite of the stuff, of the sign, so that I will eliminate my square root from the denominator. So when I rearrange now, I'm going to have 2 times all up here, and 3 minus the root of 2 plus times 3 plus the root of 2, which is really the difference of squares. 2 times 3 is 6, and 2 times the root of 2 is 2 the root of 2. 3 times 3 is 9, and 3 times the root of 2 is 3 the root of 2, and negative the root of 2 times 3 is negative 3 the root of 2. And negative the root of 2 times the root of 2 is going to be a negative number, and the root of 2 times the root of 2 is going to be the root of 4, and the root of 4 is equal to 2. Put it this way. Whenever you're multiplying the root of 2 by the root of 2, when you're multiplying the root of something by the root of the same thing, just take off on it, just take off the root of the square root sign and just put back one of the things. That's what it will always work out to be. The root of 10 times the root of 10 is going to be the root of 100, which is 10. The root of 3 times the root of 3 is going to be the root of 9, which is 3. All right, so I get the 2 here. These 2 middle pieces will cancel. That's why I multiply by the conjugate, so that we can cancel the 2 middle pieces here. So I'm just going to be left with a whole number in the denominator. And then now this now is saying that we have 6 over 7 plus 2 over 7, 2 the root of 2 over 7. So that's how I get this one. That's how I get that one. Tell me that you understand this, please.
Yes, sir.
Me not understand.
You still don't understand it?
No, sir.
What you don't understand in it, honey? Tell me.
Sir, sir, me keep on. Sir, me confused. Sir, alright. So I know saying you must multiply the something by the opposite thingy. We get that. Alright. Then they say rearrange to give me last.
Okay, all right, never mind. Let us look at a past paper. This is 2018 past paper. Oh my Lord, what did I do? Oh, come on, Mr. Shand. Okay, no, Mr. Shand, what is wrong with you? See if you want to see if you know. All right. Write the conjugate of the complex number z is equals to 1 plus 2i. What is the conjugate of z equals to 1 plus 2i?
Sir, 1 minus
1
2i.
minus
Easy 1, 2, 3. Duh. You see that no to be?
Yes, sir. I see that the part there.
Yeah. All right. Fine. Yeah, just take time. Take time.
So where's the answer, sir?
Casey, me say when Jesus lock him door, hello, Casey. Come on, man, work with teacher. You tell me, Casey, what is the conjugate of that one? C1. Cassandra, talk to me, man. I don't know. I think she's in and out.
They just put up on the spot. No.
No, but I'm saying to you, that's why you must pay attention that, hey, Jesus didn't lock him door for me, And when the door shut, when the ark shut, All right, come, Casey. No, don't lose me, Casey. Come. Remember, I was saying to you, share. Watch me, Casey. Remember, I was saying to you right here, so say, I am multiplying by the conjugate. So the conjugate of 3 minus the root of 2 is going to become 3 plus the root of 2. And I'm saying it's like creating the difference of squares. So it's 3 minus the root of 2. This time it's going to become 3 plus the root of 2. You follow me, Kes?
Yes, sir.
All right. Let me go back to the past paper now. Oopsie daisy. So it says write the conjugate of the complex number. Z is equals to 1 plus 2i. Remember, this is a real part and this is the imaginary part. What is a conjugate of z equals 1 plus 2i?
2i.
No. What is the conjugate of z equals to 1 plus 2i? It's going to be equals to what? Z is going to be equals to what? Somebody tell her for me, please.
1 minus 2i.
1 minus 2i.
Sir, someone just a while ago.
What are you saying?
Sir, I just said that a while ago. You said no.
I miss. You said 2i. That's what me hear. I don't know if anybody has heard anything else. One of your class?
Sir, and I that, sir. You sure not I that?
Yeah, but it's not just 2i. It is 1 minus 2i. All I heard
Sir, that was
was
the one. Sir, I can't see that. I made have to zoom in.
but this is 1 plus 2i. But even if you don't see it, I said it. Z is equals to 1 plus 2i. The conjugate of 1 plus 2i is 1 minus 2i. Are you seeing that now?
Yes, sir.
All right. That's 1 mark. 1 mark. Rockstone, 6 marks? 6 marks? I want to express this in the form a plus bi. So it means that you are going to be multiplying. You see this 1 plus 2i are the same 1 plus 2i up here. So the man give you a little hint, say, them want to conjugate this complex, rational complex number here. So it means that just like what Sir did right here, so by multiplying by the conjugate of it, and the conjugate is normally the denominator that we use, not the numerator, because we want to get a whole number in the denominator. We're going to, just like what I did right here, so is exactly what we're going to do right here. So that is going to be the last thing that we do in class tonight. Conjugate this one, please. Thank you. I give you 3 minutes and then we'll talk about the answer in 1 minute.
Sorry, can you go back to the example for 1 second? Thank you.
Sir, you can't.
Sir, can you go back on the example, please?
Oh, there's one thing that I need to tell you. Yeah. Press pause. Look at this. Press pause. There's one thing that I should have said to you, but I mean I got distracted. Let me work through the question with you. So what am I doing here now? So that's the example. Are you seeing the screen, by the way?
Yes.
Yes, sir.
Yes, I'm sharing. So in this example, it was straightforward, but because you're talking about a complex number now, you have to be careful with the i's. Remember, -1, the square root of -1 is equals to I. Remember, I did that. Oopsie daisy, where did I do that? See here? The square root of 1 is equals to I, don't it?
Yes, yes, sir.
All right. So I squared is going to be equals to what then? If I is equals to
-1.
+1.
+1.
-1.
No, not to be +1. Because if I is equals to -1, it means that I squared is going to be equals to the root of 1 times the root of 1. The root of 1 times the root of 1 is going to be the root of -1 times -1, which is equals to +1. And the root of +1 is +1. Talk truth.
Sir,
yes, Papi.
and so when you do that, the square root does not go away and if you number inside. It's the square root of -1 times negative, square root of -1. Oh, it's not -1.
Me too.
Unless I don't say.
Oh yeah, I see what you're saying. Yeah. I see what you're saying. Hold on, let me look at that. Because I did say to you that when you're doing the square root of, oh goodness, I just gave you an example a while ago that the root of 2 times the root of 2 is going to be 2. That's what you're talking about, right, Matthew?
Yeah.
Right. So the root of 2 times the root of 2 is going to be the root of 4, and the square root of 4 is going to be 2. Talk truth.
Yeah, I understand.
You understand that, don't? Yeah. But let us go now with the complex, because remember what I was explaining, I was explaining this here that is not a complex number. That is not a complex number. So I'm saying to you now that if I say to you So I was explaining to you in relation to this particular question, which is true. The root of 2 times the root of 2 is the root of 4, and the root of 4 is 2. This is how we get the 2 right here. So, and you did ask me a question up top, sir, how did you get the 4 right here? So, and I explained the 4 to you because the root of 4 is 2. This the root of 2 times the root of 2 is going to be 2, and 2 times this 2 is this 4. But when we're talking about a complex number now, talking about a complex number, we know that I, the square root of -1 is going to be equals to I. So therefore, I squared is going to be the root of -1 times the root of -1. The root of -1 is going to be -1 times -1, which is +1. So I squared is going to be +1.
Oh, we get it.
Bless the heart, Papa. And this is what I like, guys. I like when students ask questions. It gives me a teachable moment. All right, where am I now? So I'm going to conjugate. Well, the first part of the question asks me to conjugate it. Copy. The first part of the question asks me to conjugate it. So I am is minus. So that's what I'm having. When I conjugate it, I'm going to multiply by that. All right. Now I'm going to do the multiplication now. So the only difference with this question now is what I just explained. When you multiply the root of the i's them. Sorry, when I multiply the i's them, it makes a slight difference. That's all that there is to it. There's nothing more to it than it. I promise you. I'm going to see if I can squeeze in something like this tomorrow, so that you can at least see it. So I can get that, and then now copy, paste. And when I get this now, I'm going to say 1 times 1 is 1 times 1 is 1. 1 times minus 2i is minus 2i. Minus 2i times 1 is minus 2i. And then this is what I'm talking about now. Minus 2i times minus 2i. When I multiply two negative numbers, I'm going to get a positive number. So I'm going to get positive 4i squared. Talk truth.
Yes.
All right.
Yes, sir.
And that's the numerator. Let us look at the denominator now. 1 times 1 is 1. 1 times minus 2i is minus 2i. 2i times 1 is plus 2i. And 2i times minus 2i. When I multiply a negative number with a positive number, I get a negative number. And 2 times 2 is 4. And I times I is I squared. So that's what I will have. Let me go again. 1 times 1 is 1. 1 times, let me spotlight. 1 times 1 is 1. 1 times negative 2i is negative 2i. Negative 2i times 1 is another negative 2i. When I multiply two negative numbers, I get a positive number. And 2 times 2 is 4. And I times I is I squared. Denominator time now. 1 times 1 is 1. 1 times negative 2i is negative 2i. Positive 2i times 1 is positive 2i. When I multiply two numbers, one is positive, one is negative, the result is going to be negative. And this 2 times this 2 is a 4, and I times I is I squared. Take a minute and look at that, please. Take a minute and look at it, please. I want to make sure that you're.
Sir,
Yes, my love.
so where do you use the numerator and time?
Yes, on bunches.
Say the one negative 2i, you times it by the other one beside of it, and then at the bottom you times the other one beside of it, and that's how you get them the at the bottom.
Yes.
Okay, sir.
So is the question finished?
I just need to fix up some things. Almost finished. I just wanted for you to see what is happening there, so you can tell me. I finish in another 2 minutes. Hold on 1 minute, please, guys. Ouch.
Sir,
Yes,
sir,
yes.
so what exactly did you do? Cross multiply, because I true me see the sign them change at different places.
Yeah, man. I am distributing. I'm foiling. So I'm using one to distribute over the other. Same thing like what we normally do for factorization. Look at it and talk to me, sweetheart. Are you with me, Casey?
In filing.
What do you mean what do you mean by foiling? I'm using one number to multiply one term to multiply by the other term. I'm using one term to multiply by the other term. So let me go through the stuff again with you. 1 times 1 is 1. 1 times negative 2i is negative 2i. Negative 2i times 1 is negative 2i. And negative 2i times negative 2i. When I multiply two negative numbers, I get a positive number. 2 times 2 is 4. And I times I is I squared. Are you seeing that now, honey? I'm at the last part of the thing, and I don't want to finish it off tonight without you getting it, so just talk to me. I need to correct something with you here, Matthew. I'm coming back to you. I need to correct something that I said earlier, Matthew. Casey, talk to me now, please, so I can just do the last part.
Sir, may I look, man, sir? Give me a second, please.
Okay. Kes, come. Let me help you see, Kes. Let me help you see it. I need to correct something that I said earlier, and I don't want it to stay too much into the minds of the others. Where are we, Kes? let us go through the question again, Kes. So
get it, sir.
what did you get?
Sir, I understand how you do the multiplication and how you get each of them.
Okay, great. All right, so let me just do it one more time to seal it. So I am multiplying by the conjugate. The conjugate of 1 plus 2i is going to be 1 minus 2i. So I'm going to be multiplying the numerator and the denominator by the 1 minus 2i over the 1 minus 2i. All right, that's how we multiply by the conjugate. Now, if you can't remember that, what you need to remember is it's like you multiply by the difference of squares. It's like you multiply by the difference of squares. It's not exactly, but it favors it. It's a cousin of it. All right. So what is going to happen now? So it's going to be 1 minus 2i times 1 minus 2i in the numerator. And in the denominator, you're going to have something looking at the difference of squares. 1 plus 2i times 1 minus 2i. All right. 1, you're falling first, outer, inner, last. 1 times 1 is 1. 1 times negative 2i is negative 2i. So I finish this one with the multiplication of these two outside here. So then I'm going to use this negative 2i to multiply the same thing outside here. So each term in the first parentheses, I am using to multiply by the terms in the second parentheses. So it becomes now negative 2i times 1 is negative 2i, and negative 2i times negative 2i. Oopsie daisy, sir, I will you put something that written stages on me, sir, no problem. When I multiply two negative numbers, negative number times a negative number, give me a positive number. That is this plus 4. All right? And 2 times 2 is 4. And I times I is I squared. Similarly, 1 times 1 is 1. 1 times negative 2i is negative 2i. Finish with the 1 with everything over here, so then we can say 2i times 1 is 2i. And 2i times 2i. Hold on, sir. I would put something this again, sir. This is going stages. When I multiply a positive number with a negative number, I get a negative number. See it right here, so 2 times 2 is 4, and I times I is I squared. See it now, honey bunches? Oh, Jesus, Casey, go and left me again now. Casey.
Yes, sir.
You can't even hang in honey bunches. You heard anything I said a while ago?
So after the multiplication, we hear everything, sir.
Okay, good. So you're understanding it, right?
Yes, sir.
All right, so let me go back to what Matthew said something. I said something incorrect just now, and I need to correct it. I want all eyes on deck right here. So I was on the correct trajectory, and then Matthew asked a question, and I went off tangentially, and I need to correct it. Matthew, listen up, Papa. So earlier I said to you, generally, when we're doing the multiplication, the root of 2 times the root of 2, you just drop, since you multiply the two of them are the same thing, you just drop one of them and just put the 2. All right? So the root of 9 times the root of 9 is just going to be 9. Talk truth.
Yes, sir.
All right.
Yes, sir.
Good. I'm saying to you now, so Matthew asked a question earlier. Then, sir, why? That means the root of, that means if I is equal to the root of -1, that means I squared is supposed to be -1. And I said, no, it's supposed to be a +1. It is actually -1. So I, following the same argument that I started off with up here, so the root of 2 times the root of 2, because he asked a question from up right here, so. And that's why I put in this line. No, that's why I put in this line. Because I had a 4, and he said to me, sir, how you get the 4? And I said, the root of 2 times the root of 2 times this 2 is going to be 4, because the root of 2 times the root of 2 is going to be just 2. And then that 2 times this 2 is this 4. So the root of 2 times the root of 2 is as if you're just taking off the square root sign of one of them and just calling it 2. And then he now, based on the understanding that he got here, says to me, then, sir, that means if I is equals to the root of -1, based on what it is that you said down here, so sir. I to be equals to -1. That means I squared, sir, is supposed to be equals to -1, and he's correct. So I squared is equals to -1. Can you all see that, please, based on the explanation that we did before?
Yes, sir.
Yes, sir.
Thank you, please. I don't know what is happening. I mean, me, I them dog. But teacher made mistake to recall. If copy if if I is equals to the square root of -1. Therefore, it implies that it implies that I square is going to be equal to -1. All right, so that is going to be a given. Copy, paste. All right, so final thing that we're going to do, final thing, and then we can start gentle Jesus together. Final thing now is to just work out something. So we know that I squared is going to be equals to -1. We know that I squared is equals to -1. I squared is equals to -1. What we're going to be left with is 1, and -1 times 4 is going to be a -4. And -4 times a -1 is going to be equals to a +4. So look at what we have. And incidentally, see this piece here, so is what going to, that remember remember I was saying to you 6 marks? The piece here carry enough marks. This piece here, so carry enough marks. All right, for students to know. This is a recall part of the thing. So if I squared is -1, that means that this is going to be -1, and this is -1. I'm going to multiply +4 by a -1, I'm going to get -4. I'm going to multiply -4 by a -1, I'm going to get +4. Watch me now. -2i minus 2i is -4i, and 1 minus 4 is -3. So copy. So we have -3 minus 4i -3 minus 4i, and I'm going to have 5. Oopsie daisy. Watch me. These two cancel out. -2i plus 2i cancels out, and 1 plus 4 is 5. All right. 1 minus 4 is -3, and -2i minus 2i is -4i. So my final answer, the question did ask me to write it in the form a plus zi, is similar to what it is that I did earlier. -3/5 minus 4/5 i. Similar to what I did earlier with this question. This question and this question relates, except that this question is surds, this question is a complex, but the same conjugation for the complex, for the surds, is the same conjugation for the complex. Same concept, right? The only difference is that there's that I squares is -1. That I squares is equals to -1. All right, that's the only thing that is going to be different. So what is happening here now? When I add up all of this, I'm going to get -3 minus 4i over 5. And this will become -3/5, bam, right here, so. And this will be -4/5, bam, right here, so I. Right, so I'm going to have -3/5i minus 4/5i. Now, you may say to me, sir, why did I do that? And I'll be more than happy to answer your question. Because the question said to us, no, stop share. The question said to us, I'm trying to find, oh Lord, what the question says. Right, now I see it. The question says to us, express this in the form a plus bi. This is a real part, and this part is the imaginary part, right? B part is the imaginary part. So it says to write it in the form a plus bi, never given a fraction something. So what is a? Go back to my new share. What is a? A is going to be -3/5. What is b? B is -4/5, and the I. Can you agree with that? Can you see that?
Yes, sir.
And it's done. I'll see what can happen sometime tomorrow, or we could just wait until we do this stuff. I mean, numbers is finished right now. That's all that there is to it. And if you look at the syllabus, that's what it says. You just need to be able to conjugate the stuff. Surds in there. All of what I did tonight is what it is that it was there. Is there on the syllabus. All right. It's been a rough week. It's been a rough night. I know you guys are going through it. Had a chat with Mr. Muirhead today, and we're sharing some similar concerns. Nonetheless, we will be fine. Say, gentle Jesus, a minute, please.
Sir,
Get some, yes, honey bunches.
why for the 2i we never change that to -1?
No, because we're adding, we're not multiplying.
Oh, okay, sir.
Yeah, man, we're grouping those two together. And if we multiply, we wouldn't be able to put it in the form a plus bi. So there was some I that has to be left. So it's only when you have I squared, you will get -1. But if you have I alone, we're not changing it to a -1. The root of -1, sorry. Come on, good. All right, remember guys, you get some rest, you get up, or get some rest. I was going to say get some rest, get up and then go back to lie down, or you could do get some rest, enough rest, get up from early, and then you can get up early into us meeting at 8 o'clock in the morning, right? However you want to do it, see if you can do it for me, please. Thanks for coming out. Remember to say gentle Jesus, and you should be fine. All right? Take care, guys.
Bye, sir. Same to you.
Cool. Thank you, miss.